All right, PreCalc, we're working on the second part of lesson 4.1. We are going to talk about complementary and supplementary angles, and it's really easy to think, oh, complementary is 90, supplementary is 180, because that's kind of what we did in geometry. But now we have to start thinking about it in terms of radians. So you are right, complementary is 90 degrees. So if I gave you a 30-degree angle, the bell interrupted me, but so if I gave you a 30-degree angle, you would say the complementary is 60, because you would just take 90 minus 30 is 60. But now we need to know that two positive angles, alpha and beta, get used to these Greek letters, are complementary if their sum is pi over 2. So now we're looking at pi over 2. So in geometry, you knew that the supplementary angles were 180 degrees. So if I gave you an angle of 150, you would just take that 180 and subtract 150, and you would say that complement was 30 degrees. I forgot my 0 up there. But now we are going to learn that two positive angles are supplementary if their sum is pi. So it kind of gets a little confusing, but remember we're just dealing with pi as a variable, and we're just looking at complementary as a half pi and supplementary as 1 pi. So I'm going to write that 1/2 pi and 1 pi. So let's go ahead and look. If possible, find the complement and the supplement. Well, let's start with the complement of both of these. I know the complement is pi over 2. Can I take that and subtract pi over 6? Well, let's go ahead and make these both with a measure over 6. So 2 goes into 6 3 times, so this will be 3 pi minus pi over 6. That's going to give me 2 pi over 6, which I know can reduce to pi over 3. So the complement of pi over 6 is pi over 3. Let's go ahead and do the complement, since we're there, of 5 pi over 6. So I know again that this is 3 pi over 6 minus 5 pi over 6. Well, we end up getting a negative number. You can't call a complement or a supplement a negative. So in this case, there is going to be no complement. All right, changing colors. Let's work on supplement. Supplement of pi over 6. Well, I know that supplement was just pi or 1 pi. And I know that 1 is equivalent to 6 over 6. So I know the supplement, 6 over 6 pi minus pi over 6, will be 5 pi over 6. On the other hand, the supplement here, we're taking 1 pi and we're subtracting 5 pi over 6. Well, again, this was 6 pi over 6, and we just get pi over 6. Most of you are used to looking at circles in degree measures, so we will also get complement and supplement in degree measures, but I am thinking that you have that down. Now, this is a unit circle. It is any circle. We do call this a unit circle because it has a radius of 1. Remember, we are going to travel around the unit circle starting at 0, going around the unit circle this way. So our important measures, or what we would call our non-angle angles, and you'll see why we call those that, are 0, 90, 180, 270, and back over to 360. So we will be looking at things between degree measure and radians. To convert between degrees and radians, to convert degrees to radians, we are going to multiply the degree by pi over 180. That's just a radian. To convert radians to degrees, we're going to multiply the radian by 180 over pi. So pi is equal to 180, which we talked about, and we're just going to learn how to convert these quickly. All right, I do express not to use a calculator because sometimes you will have a quiz and not be able to use a calculator. So we are going to convert from degrees to radians. So to go from degrees to radians, we're going to multiply by pi over 180. So I'm just taking 60, multiplying by pi over 180. Well, all this can cancel out to be 3. 60 degrees is pi over 3 radians. To convert from 320 to degrees to radians, I'm going to show the degree so you see that these degrees cancel out. That's why we have the degree on the bottom. So this all cancels out. Well, 32 and 18 can reduce to 16 pi over 9 radians. And moving on to the next one, I have negative 30 degrees. I'm going to multiply that by pi over 180. These reduce to be 66, sorry, not 60, on the bottom. And we do have a negative pi over 6 radians. And let me just show you when we travel around the unit circle negatively, we are going this way. So if I went negative 30 degrees, that would be here. I'm sorry, I just went 60 degrees. Or this is marked wrong. This should be 330 right here. My degrees are marked wrong. So that is 30 degrees. And then I went negative 60 degrees. So we're going to learn more about how to travel around the unit circle as well. Now let's go ahead and express as a degree. So if I'm getting a radian of pi over 6, now I want the pi on the bottom. So I'm going to put 180 over pi because I want the pi's to cancel out. 6 and 180 degrees cancels out to give me 30 degrees. So notice we're just flipping it. We know that pi is equal to 180, and we're just going to have it one way or the other. The next question, we have 5 pi over 3. To convert that, I'm going to multiply by 180 degrees over pi. And it looks like my pi's cancel out. 3 and 180 cancel out to be 60 degrees, and 5 times 60 degrees is 300 degrees. All right, let's look at one word question. It says a circle has a radius of 27 inches. So let's go ahead and draw a circle. We know the radius is 27 inches. Find the length of the arc intercepted by a central angle of 160 degrees. Well, I know 160 degrees is not going to quite get me to the 180 that I'm going to mark here. But I know that I'm looking for this angle right here. Or I'm sorry, this arc right here. I'm going to know that for a circle of radius r and a central angle of theta intercepts an arc length s is equal to radius times theta. Theta is always measured in radians, so let's go ahead and plug in numbers. We know s is equal to r times theta. Well, let's first go ahead and convert 160 degrees to radians, because that's what we need. We know that theta was stated in radians, so we need this in radians. So I'm going to multiply this by pi over 180, and I'm going to go ahead and reduce. So it looks like this is going to be 8 pi over 9, because 16 divides by 2 8 times, and 18 by 2 9 times. So now I have my radians are 8 pi over 9, and my radius is 27. So I'm plugging that, even the pi, into my calculator, and it's asking us for the central angle of the length of the arc. So this is what we're looking for in pink. And when I put it all in my calculator with a radius of 27, I get 75 we'll just round up to 4 because it's 0.39, and this is going to be in inches.